I welcome you all to our class for today. Today we are going to consider number basis, and I want to apologize for the last time we are having this class, but we have some issues online as regards of power supply. You know the kind of country we find ourselves now, so we cannot just do that. So today, let's continue with the number basis. We are going to consider number basis. I will go straight to the point. At the end of today's class, you should be able to perform the 4 basic operations, that is the multiplication, addition, multiplication, division, and subtraction of number basis. That is one of those things you'll be able to perfectly learn how to do at the end of today's class. And at the end of today's class, you should also be able to learn number 2 on how to convert from one number basis to another. That is another thing we are going to learn. From today's class also, you'll be able to practice some simple JAMB questions, some sample JAMB questions from past JAMB UTME questions, and you are going to see how we'll solve those questions. Those questions will be typical questions that you will see in your examination. And finally, we are going to teach you how to manage your time, because time management is very important as you sit for your exam. Remember, it's going to be a CBT test exam. So we are going to do that. So let's go straight to the point. We're going to look at number bases. Now, what are number bases? Number bases are a system of counting. Now, when we talk about a system of counting in which some certain units will make up a given bundle. Now, when you are given that bundle are all placed in their various place value. The bundle has the form which are placed in their various place value. And the placing of this the next digit will equally show the value of that digit. Now, what does that mean? Counting normally is generally done in base 10, and that is what we call the binary or the decimal number. We call countings that are done in base 10, we call them the dinaries, or we call them decimal counting. That's the normal 10, 20, 15, 30, we do count on a daily basis. When we talk about the binary numbers are computer numbers, and that's the numbers we have as zeros and the 1. So when we have numbers that are zeros and 1, they are called the binary numbers. So when we talk about number basis comprises of decimal number, binary number, the octal number, which is numbers in base 8, and so many other bases. Now we're going to take just 5 keynotes, and we are going to point at those 5 keynotes as we discuss today. Those 5 keynotes will help you understand simply everything about, or everything you need to know on number basis. So the first thing we're going to look at is to consider the first keynote. And what is the first keynote? We're going to look at keynote 1. So we'll look at keynote 1. And what is keynote 1? Now, in keynote 1, there is something you must definitely note, that when you are performing basic operations, which is addition, subtraction, multiplication, and division in number basis, it is very, very advisable that because of time, you convert all such numbers to base 10, which is the normal base we use for our counting, day-by-day counting. And then when you have done that, you can now convert it to other bases, which is required in your calculation. So how do you go about doing this? Let's assume that you are given this example. If you are given a question like 6r 7 to base 10, right? And you are told that, let's take this, assume that this is in base 8, and you are told that this is equal to 511 in another base. Let's assume that this is in base 9. And you are asked to do what? To find what? To find R. Now you see that you have values given to you in two different bases, bases 8 and base 9. Now, how do you solve this question? Now, when you're dealing with question that has to do with different bases like this, and you want to carry out some basic operation that requires addition, subtraction, multiplication, and division, we always advise that you send all these values or all these bases to a common base. And what is the common base? The common base will be base what? Base 10. So you have to convert this to base 10, convert this to base 10, find the value of R, and that will be the result for this solution, because both of them, for this question, because both of them are now in a common what? In a common base. That is one thing you must bear in mind when you carry out operations that involves the basic operation, which we know: addition, subtraction, multiplication, and division. Now, keynote 2, that is the point we want to look. Now, let's look at keynote 2. We are going to look at questions on this keynote. So as we discuss this keynote, I want you to take a note of them. Now, let's look at keynote 2. In keynote 2, we're going to learn how to convert some numbers to some numbers that are in other bases. It can be numbers in base 2, base 3, base 4, base 5, and we're going to learn how to convert these to what? To base 10. Now, when you are converting numbers from other bases to base 10, we will introduce to you two different methods you can use in such conversion. The first method would look at the power expansion method. That's the normal method most of us know and most of us make good use of. Then the other method, I introduced this method, I call it successive multiplication method. Now, in this successive multiplication method, you will be required, I've tried solving a question using these two methods, and guess what? The second method is faster. So if you are sitting for JAMB, I will advise you to learn how to use the second method. And if you cannot use the second method, then you should see the need of using the first method for whatever solution or division you want to do. Now, let me look for a typical example of how we can make good use of these two different methods. Now, let me show you an example. Let's assume we have 1, 0, 1, 1 in base 2, and we are asked to convert this to base 10. Now, I'm going to use the first method, method 1. In that method 1, I will use the power expansion method. Now, in that power expansion method, we're giving 1, 0, 1, 1 in base 2. If we number this to be 0, this to be 1, this to be 2, and this will be 3, this is going to give us 1 multiplied by 2 plus 0 multiplied by 2 plus 1 multiplied by 2 plus 1 multiplied by 2. And recall, this is going to be 0, 1, 2, and what? And 3. Now, if we simplify this, you're going to have 2 to the power of 3 is going to give us 8. So we're going to have 2 times 2, 4 times 2, 8. 1 times 8 is going to give us 8. Plus 2 to the power of 4 is 2 is 4. 4 times 0 is 0. Plus 2 to the power of 1 is 2. Then 2 times 1 is going to give us 2. Plus 1 to the power, 1 multiplied by 2 to the power of 0 is equal to 1. So this is going to give us what? 1. And if you add all these, you're going to see that this is going to be 11 base 10. Now, that is the use of the power expansion method. Now, look at the time it took us to do this. Now, we're going to look at that, solve this using method 2. In method 2, we are going to use the successive multiplication method. Now, what does this method requires? We are first of all given 1, and this is the 1. We are asked to multiply that 1 by 2, which is the base, and that will give us what? 3. And that 3 will be added to the next one, which is 0, and that will give us 3. If it gives us 3, we're going to multiply this 3 by 2, which is the same base, and this will give us 6. We'll add it to the next one, which is this, and that will give us what? 7. That 7, we're going to multiply it by 2. 7 times 2 is going to give us 14, right? 7 times 2 is going to give us 14. 14, and then we'll add 1, and that will give us what? And that will give us 15 to base what? To base 10. Now, I hope we got this right. 1 times 2 is 3 plus 1, that is 3. 3 times 2 is 6 plus 1, that will give us 7. 7 times 2 will give us 14. 14 plus 1 is what? 15. Now let's look at the other method. We didn't get the first method right. 1 multiplied by 2 plus 0 multiplied by 2 plus 1 multiplied by 2 plus 1 multiplied by 2. Good. So this is going to give us 0. This is 1. This is 2. And this is 3. Right? So 2 times 2 will give us 4. 4 times 2 will give us 8. So this will give us 8 plus this will give us what? 4, right? 0 plus this will give us 2, and this will give us 1. So if we add this, we're going to have 8, 9, 10, and what? And 11 to base 10. So it's like this is giving us 2 different solutions, and then we're going to check if this is absolutely right. So this is where we got it right, wrong. So if you look at here, 1 times 2 is going to give us 2, right? So we got it wrong at that point. Now let's look at this method once more. So 1 times 2 is going to give us 2, right? We'll add 0, and that will give us what? 2, right? So the next one, we are done with 1 and 0. The next one we're going to have is 2 times 2, the base 2, which is 4. We're going to add 1 to 4, and that 1 to 4 will be equal to 5, right? Then the next thing we are going to do is to multiply 5 by 2, which is the base, and that will give us 10. And 10 plus the final one, which is going to give us what? 11 to base what? To base 10. So you see, we got the same result, right? We got the same result, and this is going to give us 11 to base what? 11 to base 10. So if you try this method, you'll come to see that this method is faster compared to this method. So what is wrong? Then using 1 times 2 to give us 3, that gives us 2, and this is absolutely what? Correct now. So you see, comparing this and this is the power expansion method, and this is the successive multiplication method. If you use these 2 methods in the examination hall, then you come to see that definitely this is what is faster compared to the other one. And that is the point you must note. Now let's look at the third note. The third thing we need to note. Now this is keynote 2. In keynote 2, when converting from one base to another, all you need to do is to use the power expansion method, or use the successive multiplication method. Now let's consider keynote 3. In keynote 3, a key point we need to note in keynote 3 is the conversion of base 10 to other bases. Now, when we are asked to convert from base 10 to other bases, we are asked to convert from bases 10 to other bases. Now, to convert from base 10 to other bases, all you need to do is to bear in mind that there is what we call successive division method. From base 10 to other bases, it's like when you are converting 77 to base 10, you want to convert it to base 3. All you need to do is to successively multiply 77 with what? With 3. And whatever the remainder is, we'll always note them. We'll always note the remainder. And at the end, we'll just count the remainders from the bottom to the top, and whatever they give us is the solution to that value. And this is what we call successive division. So whenever you are given any question to convert from 10 to other bases, you can simply do it. You have no issue but to go about dividing these with the base you are converting to. And once you do that, hope your answer will pop out. So that is keynote 3. Now, in keynote 4, you will also be required to do some certain operations. And these operations are all found in your syllabus. In keynote 4, you will be asked to convert from one base to what? Another. This is when we have from one base to another. You'll be asked to convert from one base to what? To another. Now, when we convert from one base to another, what does it mean? You can be given something in base what? In base 8, and you'll be asked to convert it to base what? To base 3. So if you are given something in base 8 and you are asked to convert to base 8, this is conversion that is made from one base to what? To another. Now, when you are carrying out this conversion, it is very, very important that when you are doing this conversion, you take these two conversions to a common base. Now, if you are given a question in base 8 and you are asked to find the answer in base 10, or you simply in base 3, all you simply need to do is convert this to base 10. That is the common base we use in carrying out our day-by-day activities. And once you get the result in base 10, what you now do is to convert from base 10, to what? To 3. And you know, converting from base 10 to 3 is very easy. All you just need to do is you divide that value by what? By 3. And that is the successive division method we discussed earlier on. So that is very easy. So whenever you are asked to convert from one base to another, base 3 to base 4, base 8 to base 7, base 5 to base 10, all you need to do is convert that value in base 8 back to base 10, right? If you convert it to base 10, do whatever you are asked to do in base 10, and then convert your results to base 3. Straightforward. Now, the final keynote we want to note today is keynote 5. And in keynote 5, which I want you to pay much attention to. There is something you must note in Keynote 5. Keynote 5 involves addition and subtraction in any base that is other than base 10. And this is done in the same way as we always do conversion from other bases to base 10 and conversion from base 2 to base 10. But this is so special that when you are doing subtraction in any base other than in base 10, what you need to do is to bear in mind that there are some exceptions that are required when you do this. And we're going to use a very serious example in doing this. When it involves addition and subtraction, you will note some exemptions, but when it involves multiplication and division, it is better for you to convert all those bases to base 10 and then do your operations in base 10 before converting to the required base. But when it is subtraction and addition of such numbers, then we have to go about doing them specifically the same way, but then there are some exemptions to that. And I'll get to show you more about that as we discuss take some samples in this discussion. Now let's consider some samples which are necessary for us to understand all the things we have discussed. We are going to take 5 different samples that you're going to find very, very interesting. All these samples are JAMB past questions. So the first one we are going to look at sample 1. And sample 1 will demonstrate to us Keynote 1. Recall Keynote 1. Keynote 1 has to do with what? Keynote 2 has to do with conversion from base from other bases to base what? To from other bases to base 3. Other bases to base 10. That is Keynote 2. And in Keynote 3, we talk about conversion from one base to what? To another base. And that is what this example will show us. Now, in this example, in this sample 1, you're going to look at sample 1. In sample 1, we are asked to convert 72 in base 6 to a number in base what? In base 3. Now, if you are given this question, you are asked to convert 76 in base 6 to a number in base 3. So how do you solve this question? Remember, in Keynote 3, we talk about converting from one base to another. And remember what I told you? I said if you are asked to convert from one base to another, the main important thing to do is to convert from that base to base 10, which is the normal basic conversion, and then the result you get, you now convert that result to base what? To base 3. Now, how do we do this? We are going to convert 72 to base 10. Now, to convert 72 to base 10, what do? We're going to convert that to base 10. We have 72 in base 6. We want to convert it to base 10. Now, remember, when you are converting from other bases to base 10, all you need to do is either you use the power expansion method or you use the successive multiplication method. And I told you that the successive multiplication method is faster. So to do this using the power expansion method, I'll simply have this as 7 times 6 plus 2 times 6. And this will give me 0 and what? And 1. Now we are going to have this to become 72 times 6 is going to give us 42, right? So we have 42 plus 2 times 1, 6 to the power of 1 is 0, is 1. So 2 times 1 is 2. And this will be equal to 40 what? 44. And this 44 is in base what? Is in base 10. Because we are converting from base 6 to base 10. Now, having gotten that value in base 10, that gives us the liberty to now convert the result, which is 44 in base 10, to what? To base what? To base 3. And once we do that, in just the twinkling of an eye, our result will pop up. Now, do you remember that if we are using as the successive multiplication method, this will just be 7 times the base, which is 6, that will be 42. And 42 plus the next one is what? 2, and that will give me what? 44 to base what? 10. Straightforward. I don't need to waste much time. And that is that. Now let's convert 44 in base 10 to base 3. Converting from other bases to from base 10 to other bases. Remember, we use what? The successive division method. So we're going to have 44, and this will be multiplied by what? 3, which is the base we are taking it back to. So 44 divided by 3 is going to give us what? 14. 14 times 3, when you have your 14 multiplied by 3, this will give us 12, and this will give us 42. So it's going to give us 42, and this will remain what? 2, because 44 minus 42 will give us 2. So we're going to have 14 divided by 3. 14 divided by 3 will give us 4, because 4 times 3 is 12. So 14 minus 12 is going to remain what? 2. 4 divided by 3 is going to give us 1. Remember what? 1, because 3 times 1 is 3. 4 minus 3 is 1. So 1 divided by 3 is 0. And the remainder is going to be what? This 1, which is there. So if you count this from the base to the top, you come to see that 72 to base 6 is equal to 1, 1, 2, 2 in base what? In base 3. And that would be the solution to that question. So you see, it's very easy. If you're asked to convert this from this base to this base, and you want to try doing it directly, you might step into or start making mistakes that will cost you a lot. And that is the point you need to note. Now, that is the question, a sample question number 1. And I know you get this. If you have any question, if you are watching the replay of this video, if you are not live with us, just drop your question in the comment section, and we're going to look at that. Now let's look at sample 2. In sample 2, we're going to look at another unique question. Sample 2, we'll look at another unique question in sample 2. Question number 2. In question number 2, we're given this. Sample 2. If 2Q3 in base 5 is equal to 77 in base what? In base 8, we are asked to find what? We are asked to find Q. So that is the value we are given. We are asked to find what? We are asked to find Q. So when we are asked to do this, that's the question we are given, and then we need to find the solution to this question. Now, remember, this is in a different base, and this is a different base. Now, remember, keynote 3 is like when you are working on, you're giving a different base, and you're giving another different base. Remember, I told you, you need to convert both of them to base 10, And once you convert both of them to base 10, which is a common base, from that common base, we can now be able to solve them. Now, let's try this. We're going to convert this to base 10 and convert this to base 10. Now, because we have a letter here, which is Q, we're not going to use the product expansion, the successive multiplication. We're going to use the what? The power expansion method. So this is going to be 0, 1, and what? 2. So that will give us 2 multiplied by 5 plus Q multiplied by 5 plus 3 multiplied by 5. And this will be equal to, we have 0, 5 to the power of 1, and 5 to the power of 2. And this is going to give us 7 multiplied by 8 plus 7 multiplied by 8. And this is going to give us 0 and what? And 1. So if you have here, this is going to give us 2 multiplied by 2 to the power of 5 is 25 plus Q times 5 is going to give us 5Q plus 5 to the power of 0 is 1, and this will give us 3. And this is equal to 7 times 8 is going to give us what? 7 times 8 is going to give us a value. 7 times 8 is going to give us, that's going to give us 7 times 2, 7 times 2, 7 times 2, and 7 times what? 7 times 2. 7 times 2 will give us 14. 7 times 2 will give us another 14, which is 28. 28, right? 28 plus 28 is going to give us 56. So that means 7 times 8 is going to give us 56. Right? Good. So that is exactly what we are going to get. So that is going to give us 56. So we'll have A to become 56 plus 7, a to the power of 1 is 1, right? Anything raised to the power of 0 is 1. A to the power of 0 is 1. So this is going to give us 7. So if we add this, we're going to have this to become 60 what? 63. Right? And this will be equal to 2 times 5 is going to give us 50, right? Plus 3, that will give us what? 53 plus 5 what? 5Q. So we're going to take this over here. So our 5Q will be equal to 63 minus 53. Because this will come here, positive, will come over here to become negative. So our 5Q will be equal to 63 minus 53 is going to give us 10. So if we divide here by 5 and divide here by 5, we'll now have our Q to be equal to 2. And that is the solution to that question. So you see, the value of our Q is equal to 2. And that is the solution to that question. So you see, by sending this to base 10 and sending this to base 10, which we did here, we're able to form a common base. And that common base made it possible for us to have the solution to that question. And this is question sample 2. Now let's consider sample 3. The key reasons why we are taking all these questions is to help you see the various methods in which your exam's questions might do what? Might come your way. Now let's consider sample 3. If you have any question, feel free to drop your answer, your question in the description or the comment section of this video. Now, in the third question, we are asked to convert, we are asked to find sample 3. We are asked to find the value one, 1, 0, 1, 1, 1, 2 plus 1, 0, 1, 0, 0 in base 2. We are asked to find the value of these two, the solution, the addition of these two values. Now, how do we find the solution to this question? Now, remember Keynote 1. In Keynote 1 has to do with what? The basic what? Operation, addition, subtraction, multiplication, and division. Now, how do we go about doing this? We're asked to find the value of this in base 2 plus this in base 2. And remember, this is sample what? Sample 3. Now, how do we do this? Now, let's write this out. We have 1, 1, 0, 1, 1, 1. And this is what? 0, 0, 1, 0, and what? And 1. And we are asked to do what? We are asked to add. So what do we do when adding these two things? Now let's flash our mind back to the rules of addition. Addition rules. I did say this when we were talking about the keynote, but we're going to see how this unfolds. Now, in our rules, we are going to consider this rule. 0 plus 0 during addition is equal to 0, right? If you have 0 plus 1 during addition is equal to 1, right? Now, if we have 1 plus 0 is equal to 1, right? Now, when we look at that, if we have 1 plus 1 is equal to 1 plus 1 in our normal addition is going to be 2, but when it has to do with addition of number bases, 1 plus 1 is not 2, but rather 1 plus 1 is equal to what? 10. So what you are going to do is you write what? You write 0 and do what? And carry what? And carry 1. Now, when you have addition of three number, 1 plus 1 plus 1, this will be equal to 11. So what you do is you write 1 and carry what? And carry 1. Right? Over to the next addition. Right? And that is exactly what you should bear in mind. Now, in some addition, we'll be doing addition of 4 numbers, 1 plus 1 plus 1. When you do this is going to give you 100. Now, take note of that. Now, what you do here is you write 0 and 0, and then you carry what? Carry 1. These are the addition rules you must bear in mind when you do carry out operations in number what? In number basis. Know these rules, bear them in mind, and see how you can solve questions like this using these rules. Now let's apply the solution to this. They're asked to add 110111 in base 2 to this in the same word base. So we have 1 plus 0 is what? Is 1. 1 plus 0 is going to give us 1. 1 plus 1 is going to give us 10. We'll write 0 and then we'll carry what? 1. Now this is the addition of 3 number bases. So 1 plus 0 is 1 plus 0 is 1. So we'll write what? We'll write 1. 1 plus 1 is what? Is 10. That is 0. We'll write 0 and then we'll carry what? 1. Now, 1 plus 1 is going to give us what? 1, right? It's going to give us 10. So we'll write what? We'll write 0 and carry what? 1. Remember, 1 plus 1 is going to give us 10. We're going to write 0 and carry 1. Now, in this point, you see nothing exists here and nothing exists here. So 1 plus 0 is going to give us what? 1. So the solution to this question, the addition of those two number in base 2 is 1, 0, 0, 1, 0, 1, 1, and it's in base what? In base 2. And that is the solution to that question that is given to us. So you see, it's very easy. Now I want you to bear these addition rules at the back of your mind because you're going to need them when carrying out operations in addition. Now, there are other operations that involve subtractions, which I also want you to know about, so that when you see questions that has to do with subtraction, you can be able to carry out the solution of those questions easily. Now, let's look at some rules in subtraction. Let me use this opportunity to show you those rules in subtraction so that you can easily bear them in mind. So what are the rules? These are subtraction rules. So when carrying out subtraction, I want you to note this, that the first thing you'll be given is when you have 0 minus 1. Now you know 0 minus 1 is not possible. You know that it won't go. So when you are doing subtraction, you're going to borrow 1. You're going to borrow 1, right? You borrow 1 to make that 0 10. Right? If you borrow 1 to that place, it will make that 0 10. So 10 minus 1 will now be equal to 1. Everything springs out from here. You see, when you add 1 to 1, it gives you 10. And when you subtract 1 from 10, it gives you, instead of 9, it gives you what? It gives you 1 back. So when you are doing subtraction and you do 0 minus 1, it's not possible. You borrow 1 to the other place, it gives you 10. 10 minus that 1 will now give you what? 1. Take note of that. Now, having done that, the next thing you should now note is when you have 0 minus 0, 0 minus 0 is equal to 0. Right? Now, when we have 1 minus 1, 1 minus 1 is equal to 0. That is normal. And when we have 1 minus 0, 1 minus 0 is equal to what? 1. So take note of this. It's very, very essential when carrying out operations in addition and subtraction. Now take note, when you are asked to convert numbers like this, when this has to do with division, when it has to do with multiplication, please don't try to multiply them and don't try to divide them. You're going to make a whole lot of mistakes. And remember, you don't have time on your side. So what I will advise you to do is quickly convert this to base 10, quickly convert this to base 10, divide this by this, get your answer, and convert your answer back to base what? To base 2. As easy as that. You will save time compared to somebody who is trying to carry out the division using base 2. And when it comes to multiplication, do same. Convert this to base 10, convert this to base 10, do your multiplication in base 10, then the result you get, convert from base 10 back to base 2. Very easy and faster. So take note of that. You're going to find it very, very easy when you carry out such operations. Now let's consider the second to the last sample. We're going to consider sample 4. Now remember, if you have any question as you are watching the replay of this live class, don't forget to drop your question in the comment section. Now let's look at the question number 4, sample 4. In sample 4, we are told that if 3 to 1 base 4 is divided by 23 in base 4 and it leaves a remainder. It leaves a remainder R. It leaves a remainder R. The question is, what is the value of R? Now, this is very, very interesting because you are given the two number bases, both in base what? In base 4. So it makes that question very, very, very interesting. So we are given 3, 2, 1, right? 3, 2, 1 in base 4 divided by 23 in base 4. So since both of them are in the same basis, we can easily solve that question. So what we are going to do is we are going to quickly convert that question, and then we'll convert it to base 10, do our normal solution in base 10, and then convert our result to base what? To base 4. Remember, your solution must be in base 10. But since they say you should find the remainder, so that means if we convert them to base 4, we are just simply going to get the answer straightforwardly. Now, I bet you, if you go ahead to go about doing your 3, 2, 1 divided by 23, since they are both in base 4, the remainder you get will be very wrong. Now, if you try it, you're going to see that you're not going to get the same result. With the person who does the same method, we're going to use. Now, use your calculator and point 321 divided by 23. And what will you have? You have 13.9. And your remainder will not be even close to what? Will not be even close to what? To 9. And that is exactly why I said you can't use what? You can't use this method. Now let's do that quickly. We're going to convert this to base 10, convert this to base 10. Remember, you can't do that directly because our normal operations, addition and subtraction, are usually done in base what? In base 10. So let's convert this to base 10. We'll have 3, 2, 1, 4. We're going to convert it to base 10 to base 10. Remember, converting other bases to base 10, I told you use two different methods. You can use the power expansion, and you can use the successive multiplication. So I'm going to use the power expansion for this, and I'll use successive multiplication for the second one, so that we can learn these two methods. Whichever you find easier, you can use during your examination. So we'll have this to become 3. Remember, you write the 3, you multiply it by 4, which is base, and this will give you 12, right? You add 12 to 2, right? And that will give us what? 14, right? 14, you multiply it by 4, which is the base. 4 times 4 will give us 16. 4 times 1 will give